Hello and welcome. Tonight, let's take a slow journey together, not a journey of distance, but of thought, of curiosity. Imagine yourself wrapped in quiet, the day behind you, the night stretching out ahead. In this stillness, science becomes less of a lecture and more of a lullaby, each mystery a soft note carrying you further into rest. For all that humanity has discovered, the planets we've mapped, the particles we've named, the galaxies we've photographed across the dark, there is still so much that lies beyond our reach. The universe remains full of puzzles, paradoxes, and unanswered questions. They stretch across billions of light years, hidden in the silence of black holes, and they ripple beneath our very feet, in the oceans, the atmosphere, and even in the mysterious workings of our own bodies. Science is not a finished book of truth. It is a story still being written, page by page, with vast blank spaces between the words. Each question is not a wall but a doorway, and beyond each doorway lies wonder. To pause at these thresholds is to remember that we are explorers, fragile and curious, in a cosmos far larger than we can comprehend. Think of the stars above you right now. Each one is a sun, burning across unimaginable distances, and yet, for all their brilliance, even they are bound by mysteries. Why they shine, why they collapse, why they sometimes pulse or explode, we know part of the story, but not all. And in between the stars is even more mystery, the great darkness that holds them, a silence that is not empty at all, but woven with hidden forces and invisible matter. Tonight, we will drift through these mysteries gently, not to solve them, but to cradle them in thought, the way you might hold a seashell and listen to the faint sound of the ocean inside. Each unanswered question is like that a soft echo of the universe, reminding us that there is always more to hear, more to wonder about, more to dream. If you find comfort in this way of listening to science, you can always return here. You can subscribe or share these thoughts with others who, like you, may need a calm place to drift off while still feeling connected to something vast and meaningful. But for now, you don't need to do anything. No answers are required. Let the questions carry you. Let the mysteries settle like starlight across your thoughts. And if you are ready, let's begin with the oldest and deepest question of all. Why does the universe exist at all? Why is there something instead of nothing? Close your eyes for a moment and picture emptiness. Not a quiet room, not a night sky, but something deeper, the idea of true nothingness. No stars, no atoms, not even space or time. Just a silence without form. And now, imagine the sudden presence of everything. Galaxies, stars, planets, light, and you. The leap between nothing and something is perhaps the most profound mystery of all. We live inside a universe filled with matter and energy, ruled by laws of physics that seem precise and reliable. Yet the most basic question remains unsolved. Why is there a universe at all? Why should there be something instead of nothing? Physics can describe how the universe behaves once it exists. We can trace cosmic history back to the Big Bang, watch galaxies forming, even measure the faint glow of the early cosmos. But no telescope, no particle collider, no scientific tool has ever explained why there is existence in the first place. Quantum physics suggests that what we call nothing may not be empty at all. Even the vacuum of space flickers with activity particles appearing and vanishing like whispers of possibility. Some scientists imagine that our universe itself may have begun this way, a vast fluctuation born from instability. Perhaps nothing is simply too unstable to last, and so something always emerges. Others stretch the picture even further. They suggest that our universe may not be alone, but one of countless universes in a vast multiverse, each with its own rules, its own laws of nature. If that is true, then our existence is just one note in a cosmic symphony. Yet this idea, as grand as it feels, only deepens the question. Why should there be a multiverse at all? Why should reality exist in any form, in any number, instead of never existing? Philosophers sometimes take a simpler but stranger view, that existence is the natural state, and non-existence is impossible. Perhaps reality, in some form, must always be. But here, too, we meet a boundary we cannot cross. These are questions that no experiment can settle, no equation can solve. And yet, in the quiet of night, this great mystery becomes less frightening and more soothing. Every star you see, every atom in your body, every thought drifting through your mind exists only because existence itself was chosen over nothing. The fact that reality is here at all, that we are here, is the deepest wonder of all. As you breathe gently now, imagine that your breath itself is part of this mystery, part of a story without a beginning we can see. Perhaps the greatest comfort is not in finding the answer, but in knowing that we are part of the question. Let's travel back, as far as the mind can stretch. Nearly 14 billion years ago, before stars, before planets, before even the notion of time as we know it, the universe was condensed into something smaller than a grain of sand and infinitely stranger. In a single instant, it expanded, not into empty space, but creating space itself, stretching the fabric of reality outward like a vast balloon. We call this beginning the Big Bang, yet the name is almost misleading. It was not an explosion in space, but the birth of space and time together. From that first spark, everything we know began its journey. Light, matter, the seeds of galaxies. The universe swelled, and in the blink of an eye, it was a hot, dense fireball. In those earliest fractions of a second, something extraordinary may have happened. Inflation. Space itself may have blown wide open, expanding faster than even light could travel. Imagine a tiny point unfolding into something vast, smooth, and uniform a canvas, on which the later brushstrokes of stars and galaxies would be painted. But what triggered this inflation? Why did it begin, and why did it stop? These questions remain unanswered, hidden behind the veil of that first moment. Some theories suggest the Big Bang was a quantum tremor, a fluctuation in the deep fabric of reality itself. Others picture it as one heartbeat in a cosmic cycle, one of many births and deaths of universes, expanding, collapsing, and beginning again. And then there is the even stranger puzzle. If the Big Bang was also the birth of time, then asking what came before may not even make sense. Before might be a word that has no meaning in that context, like asking what lies north of the North Pole. Our instruments, the Hubble Space Telescope, the Planck satellite, and the new James Webb have given us glimpses of the infant universe. They can see nearly back to the first glow, capturing a sky filled with light that has traveled for almost the entire history of time. But none can peer into the very first instant. That spark remains hidden, a mystery still resting in the dark. So tonight, as you listen, imagine the universe as a storybook opening, with its first line unreadable, its first word lost to silence. We know the pages that follow the galaxies, the stars, the birth of life, but the first word, the true beginning, is still missing. And perhaps that is as it should be. A mystery too deep for answers, too gentle for finality. As you drift deeper into thought, picture the Big Bang not as a noise or a blast, but as the quiet unfurling of a cosmic flower, petals opening into space, carrying with them everything we are and everything we will ever know. Every moment, we feel it, the quiet pull of time moving forward. The present slips into the past, like sand flowing through unseen fingers. We remember yesterday, but not tomorrow. A broken cup never leaps back together. The warmth of hot coffee seeps away into the air, never the other way around. Time, in our experience, only flows one way, and this one-way direction is what scientists call the arrow of time. What makes this arrow strange is that the deepest laws of physics don't require it. At the smallest scales, particles can move forward or backward in time with equal ease, their equations perfectly symmetrical. Nothing in the math demands that time should always march forward. And yet, for us, the arrow is absolute. We cannot return to the moments that have passed. We can only move onward. Many scientists connect this mystery to entropy, the tendency for disorder to grow. A tidy room becomes messy without effort, but a messy room never cleans itself spontaneously. The universe, too, began in an exceptionally ordered state, and has been unraveling ever since. This slow increase of disorder may be the hidden engine behind time's arrow. But then another question arises. Why did the universe begin in such an ordered state at all? Why was the cosmos so improbably tidy at the start that time itself could have a direction? Some theories suggest that the arrow of time is tied to the expansion of the universe, the spreading of galaxies, the unfolding of space. Others wonder if it emerges from the way information spreads and cannot be gathered back again. None of these explanations is complete. The arrow remains a riddle. And yet, there is something comforting in its inevitability. Time's flow is the current that carries us through life. It allows us to remember, to learn, to grow. Without it, there would be no stories, no music, no unfolding of dreams. The same arrow that moves the stars in their courses also moves us gently through our days and nights. As you breathe, feel the arrow of time flowing through you, steady and calm. Each breath is a moment that will never come again, yet it leaves behind a trace, a memory, a ripple, a mark in the story of your life. You are carried, softly, on the same current that carries galaxies across the ages. And so, as we drift deeper, we arrive at the next hidden force, an invisible mass that surrounds us, shapes us, and holds the cosmos together. Something we cannot see, but which makes up most of the universe: dark matter. When you look up at the night sky, every star you see seems to be held delicately in place, as though the galaxy were a vast wheel spinning in balance. But when astronomers measured those motions, they discovered something unsettling. The stars at the edges of galaxies move far too quickly. By all logic, they should drift away into the emptiness of space. And yet, they stay bound, as though an unseen hand were holding them together. The conclusion was inescapable. Most of the mass in the universe is not the kind we can see. It does not shine. It does not glow. It does not block light. This hidden presence, exerting gravity but remaining invisible, has been named dark matter. Dark matter reveals itself only through its pull. It holds galaxies together, shaping their elegant spirals. It bends starlight from distant clusters, creating strange mirrored images in the sky. It leaves faint ripples in the grand web of cosmic structure. But though we know it must be there, its true nature remains a mystery. What is dark matter made of? Scientists have searched for decades. Some believe it consists of particles we have not yet discovered, ghostly entities that barely touch ordinary matter. They call them WIMPs, weakly interacting massive particles. Others imagine axions, even lighter and stranger particles, humming through the universe like invisible fog. There are even theories that dark matter might be ancient black holes, formed in the earliest seconds after the Big Bang. Deep underground, in silent laboratories shielded from the noise of the surface world, detectors wait patiently. They are designed to capture the faintest hint of a collision, a passing dark matter particle brushing against an atom. So far, the silence has endured. Not a single confirmed particle has revealed itself. And yet, we cannot deny its presence. Dark matter outweighs all the ordinary matter, the stars, the planets, the living creatures by a factor of 5. It is the unseen foundation of the cosmos. Without it, galaxies would not exist, and the universe would be unrecognizable. Sometimes, when you step outside at night and gaze into the dark, you might imagine it as empty space, but in truth, that darkness is full. It is filled with something we cannot see, something ancient and quiet, holding the very stars in their places. Dark matter is the silent companion of every galaxy, the invisible thread woven through the night. And just beyond this hidden mass, there is another mystery, even stranger. Not only is the universe expanding, but it is doing so faster and faster, as though pushed apart by a force we cannot see. an invisible energy, vast and unstoppable. We call it dark energy. In the late 1990s, astronomers made a discovery so surprising that it reshaped our picture of the universe. By studying distant supernovae, stars exploding with brilliant light, they expected to find that the expansion of the universe was slowing down, as gravity gradually pulled everything inward. Instead, they found the opposite. The universe was not slowing. It was speeding up. Some hidden force, was pushing galaxies apart with increasing strength. This invisible presence was given a simple name, dark energy. And though the name is plain, the mystery is vast. Today, scientists believe that dark energy makes up nearly 70% of all that exists. 7 out of every 10 parts of the universe are composed of this unseen energy. It does not shine or pull, but instead acts like a deep breath expanding the fabric of space itself. With each passing moment, galaxies drift farther and farther away, as though carried on an endless tide. What is dark energy? No one knows. Some describe it as a property of empty space, the energy of the vacuum itself. Others see it as a new kind of cosmic field, filling the universe the way air fills a room. And there are more daring ideas, that dark energy may not be constant at all, but could change over time, growing stronger, shaping the future in ways we cannot yet imagine. The fate of the cosmos may rest in this mystery. If dark energy remains steady, the universe will continue to expand, its galaxies growing ever more distant, its stars slowly burning out. Billions of years from now, the night sky may darken, until no starlight remains, a quiet, fading into coldness, a fate called heat death. But if dark energy grows stronger, the expansion could become violent. Galaxies, stars, planets, and even atoms themselves could be torn apart in what scientists call the Big Rip. And still, there is the possibility that dark energy might weaken, allowing gravity to regain its hold. In that case, the universe could collapse inward again, perhaps giving birth to a new beginning after the end. We do not know which future awaits. The only certainty is that dark energy is here, carrying us outward on its invisible tide. Every second, the universe grows, space itself stretching between the stars. It is as if creation has never truly stopped. The unfolding continues, quietly, endlessly. As you drift with this thought, imagine yourself floating on that tide, carried outward gently with the galaxies. The silence between stars grows wider, but you are not lost. You are part of the expansion, part of the great breath of the cosmos. And in this expanding sea, another puzzle waits. For even as the universe grows, it seems balanced in a way that makes life possible. A fine-tuned harmony, delicate and improbable. A question that leads us to the next mystery. Why does the universe seem built for life? The more deeply scientists study the universe, the more it begins to look like a delicate instrument, tuned with precision. The laws of physics, the speed of light, the strength of gravity, the charge of the electron, all rest on exact values. If they were even slightly different, our universe might be unrecognizable. If gravity errs stronger, stars might burn too quickly, collapsing before planets had time to form. If it were weaker, stars might never ignite at all, leaving the cosmos dark and lifeless. If the electromagnetic force varied, atoms themselves could not exist, and chemistry, the language of life, would vanish. Even the balance between matter and antimatter in the first seconds after the Big Bang had to fall ever so slightly toward matter, or else the universe would have cancelled itself out in a flash of nothing. This strange balance is called fine-tuning. It is as though the cosmos were a stage set with care, each light, each sound, each detail arranged for the possibility of life. And yet, we do not know why. Is it chance? Is it necessity? Or is it something else, hidden beyond our understanding? Some scientists suggest the multiverse may hold the answer: countless universes, each with its own physical laws, each playing with different settings of the cosmic dials. Most of those universes, if they exist, would be sterile, silent, unable to support life. But in a few rare cases like ours, the conditions might fall into just the right range for stars, planets, and living beings to emerge. In that picture, we exist not because the universe was designed for us, but because only in such a universe could we exist at all. Others wonder if fine-tuning hints at a deeper principle, still undiscovered a hidden law that makes these numbers inevitable. Perhaps the values are not accidents, but woven into the very fabric of reality. Or perhaps the fine-tuning puzzle is simply a question we are not yet ready to answer, a mystery meant to remind us of our fragility and our fortune. For tonight, consider this. Every breath you take depends on this delicate balance. The stars that forged the elements of your body, the planet that cradles you, the warmth of the sun, all are possible because the universe sits on a razor's edge of harmony. Existence itself, balanced like a candle flame against the wind. As you let that thought settle, imagine yourself as part of this harmony, a quiet note in a grand cosmic song. And with that song in mind, let us drift farther to the question of how wide the universe truly island. Does it end, or does it go on forever? When we gaze at the night sky, it feels endless. Stars scattered without boundary, galaxies glowing faintly beyond. But the universe we can see is not infinite. It has an edge, a horizon. Beyond that horizon, light has not had time to reach us since the beginning of the cosmos. The universe is nearly 14 billion years old, and in that span, light can only travel so far. That limit forms a cosmic curtain, the observable universe. Within this horizon lies everything we can measure: 2 trillion galaxies, each with billions of stars. It is an ocean beyond comprehension, and yet it may be only a small pool in something much larger. What lies past the horizon? We cannot say. The universe could stretch on without end, or it could curve back on itself like the surface of a sphere, looping in ways our minds struggle to picture. If space is infinite, then the galaxies continue forever, each cluster mirrored again and again, scattered into eternity. But if the universe is finite, then perhaps, traveling far enough, you could one day return to the point where you began, like walking the surface of the Earth until you circle the globe. The shape of the universe remains uncertain. Observations suggest it is flat, balanced between open and closed, as if tuned to perfection. Yet even a flat universe can be infinite, sprawling without end. The numbers we measure hint but do not decide. And so, we stand within a mystery. The night sky above you may be a window onto all that exists, or it may be just one small patch of a far vaster quilt. Whether infinite or bounded, whether eternal or fleeting, the cosmos stretches beyond our reach. In a way, this horizon is comforting. The limit is not a prison, but a gentle veil, reminding us that mystery remains. Beyond what we can see may lie wonders our minds have not yet imagined. So as you rest, imagine standing at the edge of the observable universe. Behind you glows everything we know: stars, planets, galaxies. Ahead lies a silence we cannot see, an uncharted sea of possibilities. The boundary between known and unknown is not a wall, but a soft twilight, a place where wonder grows. And beyond that twilight, perhaps, lies something even stranger. Whole regions of space-time that we can never touch, entire universes beyond our own, a reality larger than all horizons combined. When we look deep into space with powerful telescopes, we are also looking back in time. Light takes billions of years to reach us, so each galaxy we see is a memory, a portrait of how it looked ages ago. The most distant light we can observe began its journey more than 13 billion years ago, when the first galaxies were just beginning to form. Beyond that lies the afterglow of the Big Bang itself, a faint cosmic whisper called the cosmic microwave background. But there is a veil we cannot pierce. We cannot see beyond that glow, because the universe was once too hot and dense for light to travel freely. Before that moment, the cosmos is hidden from us. The earliest chapters of existence remain locked away, invisible to all instruments. And even within today's cosmos, there are places forever beyond our reach. The universe is expanding, and the most distant galaxies are carried away faster than light itself. Their light, though it streams toward us, will never arrive. They recede into darkness, vanishing beyond the edges of possibility. Those realms are real, yet unobservable, a cosmos hidden within the cosmos. Some theories suggest that our universe is not a single whole but part of an eternal inflation. In this picture, space-time itself constantly births new regions, like bubbles in an infinite sea. Our observable universe is just one bubble, drifting beside countless others, separated by horizons we can never cross. Each bubble may hold different laws of physics, different possibilities, different stories of existence. It is humbling to realize how small our view truly island. Even with our most advanced tools, we can only glimpse a fraction of the whole. Like standing at the shore of an endless ocean, we see only the waves at our feet, while the vastness stretches unseen beyond the horizon. And yet, there is beauty in this limitation. Mystery gives the universe its softness, its quiet invitation to wonder. If we could see everything, perhaps awe would fade. But with so much hidden, the cosmos becomes not just a place of facts, but of dreams. So, tonight, let your imagination drift beyond the horizon. Picture galaxies too far to reach, clusters of stars that will never shine in our skies. Imagine them as glowing lanterns, drifting away into eternity, still part of the same grand universe, even if forever unseen. And from this vision, another question arises. If there may be more than we can see, could there be more than one universe? Could our cosmos be only one of many, part of a vast multiverse? Imagine our universe as a single bubble, floating in an endless sea. Now imagine countless other bubbles drifting beside it, each one a universe of its own, with its own stars, its own laws of physics, its own possibilities. This is the idea of the multiverse, a reality not of one universe, but of many. In some versions, every universe begins with its own Big Bang, each a spark in the fabric of eternity. Some might be vast and filled with galaxies like ours. Others could be brief flickers, collapsing almost as soon as they appear. Some might be strange beyond imagining, with no matter, no light, or perhaps with forms of life unlike anything we know. The multiverse is not just a dream of philosophy. Certain branches of physics hint at it. Eternal inflation, the process that may have shaped our own Big Bang, suggests that new regions of space-time are always forming, each cut off from the rest. String theory, with its many possible shapes of hidden dimensions, also points toward a multitude of possible universes. But here lies the paradox. If other universes exist, they are beyond our reach. No telescope can see them, no experiment can touch them. They may be real, but unprovable. For some, this makes the multiverse unsatisfying, an idea that slips through the fingers of science. For others, it is inspiring, a reminder that reality may be larger, stranger, and richer than we can ever measure. Think for a moment about what it means if the multiverse is real. Somewhere, perhaps, there is a universe where gravity is stronger, where stars burn twice as fast. Somewhere, there is a universe where no stars shine at all. And perhaps, in an infinity of possibilities, there are universes almost identical to ours, with galaxies like our own, planets like Earth, and maybe even reflections of us walking under skies nearly the same. Whether or not the multiverse exists, the idea expands our imagination. It reminds us that our universe, vast as it feels, may be only one note in a cosmic symphony, one story among endless others. So as you rest, let your mind drift outward, past our galaxies, past our horizons, into that sea of possibility. Picture bubbles of light and darkness, each one cradling its own version of existence. You are here, in this bubble, but you are also part of a greater whole, a mystery without end. And as we hold this image, we return to our own cosmos, to the fabric it is woven from, space and time themselves, the stage upon which all universes play their song. When you stand still and look around, it may feel as though space is simply emptiness, a quiet backdrop against which everything else happens, and time feels like a steady river carrying moments forward. But physics tells us that space and time are not separate, not simple, and not empty. They are woven together into a single fabric, space-time. Einstein showed us that this fabric is alive, able to bend and curve. Planets and stars do not merely sit in space, they shape it. Their mass presses into the fabric, creating valleys and slopes. Other objects then move along those curves, and what we call gravity is simply the shape of space-time itself. The Earth orbits the Sun, not because it is pulled, but because it is following the curve of the Sun's presence. We see echoes of this curvature across the cosmos. Light from distant galaxies bends around clusters of matter, creating arcs and mirrored images, as though space itself were a lens. Time, too, can be stretched. Near a black hole, where the fabric is drawn tight, a single hour for one observer might pass as years for another. Space and time are not rigid. They are pliant, like cloth rippling in the wind. And yet, on the smallest scales, a new puzzle emerges. If you could zoom down to the tiniest fragments of reality, some scientists believe space-time itself might not be smooth at all. It might shimmer and froth, filled with tiny fluctuations, a quantum foam bubbling with possibility. Others suggest that space-time may not even be fundamental. It could be something emergent, like a pattern arising from something deeper, something hidden. If that is true, then the stage on which the universe unfolds may itself be only an illusion, a surface hiding a more profound reality. These are not questions with easy answers. We do not yet know what lies beneath space-time, or whether it is the ultimate fabric, or just one layer in a greater tapestry. But there is wonder in knowing that even the ground beneath our feet, even the ticking of our clocks, may be part of a mystery still unfolding. So, as you breathe slowly, imagine yourself resting on that fabric, a gentle ripple in the sea of space-time. Every heartbeat, every moment, is a thread in that vast weave, connecting you to stars, to galaxies, to the beginning and beyond. And within this woven fabric lies another strangeness, one that defies ordinary intuition, the realm of quantum physics, where particles can be in many places at once. If the universe feels vast and mysterious on the scale of galaxies, it becomes even stranger when we look at the tiniest building blocks of reality. In the world of quantum physics, particles do not behave like tiny marbles or specks of dust. They act more like whispers, like possibilities. One of the most haunting ideas in this realm is called superposition. It means that a particle can exist in multiple states at once. An electron can be here and there, spinning this way and that way, all at the same time. Only when we observe it does it seem to choose a definite outcome. The most famous demonstration of this comes from the double-slit experiment. Imagine sending single particles, one at a time, through two narrow openings in a screen. If you do not measure which slit they pass through, they behave like waves, interfering with themselves, creating patterns as though they went through both slits at once. But if you watch closely, if you ask, "Which path did you take?" the pattern vanishes. The particles behave like solid objects, choosing one slit or the other. The experiment has been repeated with not just tiny electrons, but with larger particles, even molecules made of hundreds of atoms. The strange truth seems to persist. The world at its foundation is not made of solid certainties, but of shimmering possibilities. What does this mean for reality? One interpretation suggests that all possibilities are real, branching into different versions of the universe. The many worlds interpretation. Every choice, every outcome, spins off into a separate world. In another version, the wave of probability is not real at all, but simply a way of describing uncertainty. And still others believe the answer lies in some deeper, hidden layer of physics, not yet revealed. Whichever picture is true, the lesson is the same. At its roots, Reality is not solid, but fluid. The foundations of matter and energy hum with uncertainty, with possibility. As you drift in thought, imagine the particles that make up your body, your hands, your heartbeat, your breath. At the deepest level, they are not fixed things, but clouds of possibility, constantly shifting, constantly choosing. You are a being made not only of matter, but of wonder. And as strange as superposition is, there is something stranger still, a connection that binds particles across space, no matter how far apart they travel. A phenomenon Einstein once called spooky action at a distance. It is known as entanglement. In the quiet world of quantum physics, there is a phenomenon so mysterious that even Einstein doubted it could be real. It is called entanglement, a deep connection between particles, linking them no matter how far apart they may drift. Imagine creating two particles together, like twins, born from the same spark. Once entangled, they share a bond beyond distance. If you measure one, the other responds instantly, even if it is on the far side of the universe. It is as though they are still part of the same whole, speaking in a language faster than light, woven into the same invisible thread. Einstein called it spooky action at a distance, because it seemed impossible, a violation of everything physics should allow, but countless experiments have shown it is real. When entangled particles are tested, their properties line up in perfect harmony, in ways that cannot be explained by chance. What does this mean? Some believe it reveals that information is carried in ways we do not yet understand. Others think it shows that particles are not truly separate things at all, but part of a deeper reality beneath space and time. Entanglement may be the faint outline of a hidden structure, one that connects everything in the universe. Beyond being a puzzle, entanglement also opens doors. Quantum computers, now being built around the world, rely on this phenomenon to perform calculations far beyond the reach of ordinary machines. One day, quantum entanglement might reshape technology, communication, even our understanding of knowledge itself. But tonight, it can be thought of more simply as a reminder that separation may be an illusion. Just as entangled particles remain connected, perhaps all things are linked at some hidden level. You and the stars, the oceans and the galaxies, all part of the same quiet web of being. So as you breathe slowly, imagine a soft thread of light connecting you to everything, to the people you love, to the earth beneath you, to the stars that shine across the night. In the stillness of the universe, nothing is ever truly alone. And yet, a question lingers. Why does the universe behave this way? Why should observing something change it? The next mystery waits at the edge of knowledge, the role of observation itself. In the quantum world, one of the strangest truths is that the act of observing can change reality. Before a particle is measured, it exists in a cloud of possibilities here and there, spinning this way and that. But when we observe it, the cloud seems to collapse into a single outcome. It is as if the universe waits for us to look before deciding what to be. This is called the collapse of the wave function, and it has puzzled scientists for nearly a century. What counts as an observer? Is it a measuring device, a human mind, or simply any interaction at all? No one truly knows. Some theories suggest that consciousness plays a role, that awareness itself somehow helps shape the physical world. Others believe the collapse is not real at all, but just the appearance of certainty when possibilities interact with their environment. The mystery deepens when we remember that we too are made of quantum particles. The atoms in your body follow these same strange rules. Yet, somehow, when gathered together, they create a world that feels solid, certain, and predictable. How does the shimmering possibility of the quantum realm become the familiar reality of daily life? The answer remains hidden. For many scientists, this puzzle is not just about physics, but about meaning. If the universe responds to observation, then perhaps our presence is more deeply woven into reality than we ever imagined. We are not just watching the cosmos from the outside. We may be part of the mechanism by which it unfolds. As you lie here, Think of yourself not only as a traveler through the universe, but also as a participant in its story. Every glance, every moment of awareness, is like a brushstroke on the canvas of reality. The universe is not indifferent to you. It changes when you look. This thought, gentle and strange, brings us to another puzzle. Of all the forces in nature, one seems weaker than it should be, quieter than the rest, yet it shapes the largest structures in the cosmos. It is gravity, the most familiar force, and still, one of the greatest mysteries. Gravity is the most familiar of all forces. You feel it every moment, pulling you gently toward the Earth. It holds the moon in orbit, guides the planets around the sun, and shapes the arcs of galaxies. It is the quiet architect of the cosmos. And yet, compared to every other fundamental force, gravity is astonishingly weak. Think of it this way. A simple refrigerator magnet, small enough to fit in your hand, can lift a paperclip against the entire pull of the Earth. That tiny magnet is overcoming the gravity of a whole planet. Why is gravity so feeble when its influence is so far-reaching? Physicists call this puzzle the hierarchy problem. The strong nuclear force binds the cores of atoms. The electromagnetic force lights the stars. The weak nuclear force powers the sun's fusion. All three are unimaginably stronger than gravity. And yet, without gravity, the universe would have no structure at all. Stars and galaxies would never have formed. Some theories suggest that gravity may not actually be weak, but that much of its strength leaks away into hidden dimensions beyond our perception. Imagine gravity flowing like water, not only across our familiar universe, but also into unseen realms, curled up in the fabric of space itself. Others propose that new laws of physics, still undiscovered, may explain why gravity behaves differently from the other forces. Whatever the answer, the weakness of gravity is also its gift. If it were stronger, the universe would collapse quickly into dense knots. If it were weaker, matter would never gather into stars. The balance is delicate, as if the cosmos has tuned gravity to just the right note, allowing the long, slow unfolding of life and light. As you breathe in, think of gravity not just as a force, but as a kind of gentle embrace, the quiet hand that holds us close to the Earth, and the invisible thread that binds galaxies together. It may be faint, but it is everywhere, and it is enough. And yet, even with gravity, we face another paradox. The two greatest theories of physics, Einstein's elegant relativity and the strange probabilities of quantum mechanics, both work perfectly, but they refuse to fit together. What happens when we try to unite them? That is the next mystery. In the early 20th century, science gave us two masterworks. One was Einstein's general relativity, a theory that revealed how gravity bends space and time, shaping the vast stage of the universe. The other was quantum mechanics, a set of rules that described the smallest things, atoms, particles, and the flickering probabilities of the subatomic world. Each theory works with astonishing precision in its own domain. Relativity explains black holes, the motion of planets, and the expansion of the universe. Quantum mechanics explains chemistry, electronics, and the delicate dance of particles. Both have been tested to extremes, and both are unfailingly accurate. But when they meet in places where the very large and the very small collide, such as inside a black hole or in the instant of the Big Bang, the harmony breaks. The math collapses into infinities, equations refusing to settle. Relativity paints a smooth, continuous picture of space-time, while quantum mechanics insists that everything flickers with uncertainty and granularity. The two descriptions cannot agree, and yet reality must contain both. For decades, physicists have sought a unifying framework, a theory of everything. Some imagine strings, tiny vibrating filaments of energy, weaving together all particles and forces into one cosmic symphony. Others explore loop quantum gravity, in which space and time themselves are woven from tiny loops, like threads in a tapestry. But so far, no experiment has revealed the true answer. It is a strange paradox. Our two best maps of reality, each brilliant in its own way, cannot be laid on top of one another without tearing. And so the ultimate picture of the universe remains unfinished. As you rest, you might imagine the cosmos as a puzzle with two half-completed corners. One shows the grand spiral of galaxies. The other shows the hidden shimmer of particles. The missing piece between them is still out there, waiting. Perhaps one day, humanity will find it. Perhaps the universe will keep this secret forever. But one thing is certain. The place where relativity and quantum meet is also the place where mysteries deepen most, in the heart of black holes and in the birth of time itself. Black holes are among the strangest children of Einstein's equations. They are places where gravity grows so strong that nothing, not even light, can escape. To us, they appear as dark silhouettes, outlined only by the glow of matter spiraling into their embrace. Yet their true centers remain hidden, wrapped behind the veil of the event horizon. According to relativity, everything that falls into a black hole is crushed toward a single point of infinite density, a singularity. Infinity, though, is often a sign not of truth but of broken mathematics. It suggests that our theories, so reliable elsewhere, fail in this extreme. What truly lies at the core of a black hole, no one can say. Some physicists imagine that the singularity is real, a boundary where space and time themselves collapse. Others believe that a deeper theory, perhaps quantum gravity, still unborn, will smooth away the infinity, replacing it with something finite and describable. Perhaps the heart of a black hole is not a point, but a knot of space-time, a loop, or even a doorway to something else. We cannot look inside. The event horizon seals it away completely. Not even the most powerful telescope can pierce that shroud. And so the black hole's center remains one of science's most inaccessible mysteries, a truth hidden in darkness, waiting in silence. And yet, this puzzle is not confined to black holes. The Big Bang itself may have begun with a singularity, the entire universe compressed into a single, indescribable point. If we could understand what singularities truly are, we might glimpse the origin of everything. As you drift deeper into calm, imagine the universe as a book. Black holes are pages glued shut, chapters we cannot yet read. They remind us that for all we know, there are still places where knowledge stops and mystery begins. A singularity is a place where our understanding breaks. It is where equations predict infinities, density without limit, time and space collapsing into something beyond definition. Black holes, according to relativity, contain them. The Big Bang, too, may have begun with one. But what are they, really? Some physicists believe singularities are actual features of nature, real points, where the known laws of physics come undone. Others see them as warning signs, telling us that Einstein's theory, magnificent as it is, cannot carry us all the way into the deepest depths. Somewhere beyond, a new theory must take over, one that merges relativity with quantum mechanics, weaving them into a seamless whole. In that theory, the infinities might vanish, replaced by something we can describe, something finite and real. But until that deeper framework is found, singularities remain like locked doors at the edge of knowledge. They mark the places where our vision fails, where the language of math itself falters. What lies on the other side is hidden from us, like a room just beyond the glow of a lantern. There is something humbling in this. Singularities remind us that the universe is not obliged to be fully known, at least not yet. They are reminders of mystery, written into the very heart of existence. And connected to this mystery is another, even more troubling. When matter falls into a black hole, it seems to vanish, but information, the details of what that matter was, should never be lost. What happens to it? That is the paradox we face next. When something falls into a black hole, it seems to disappear forever. Stars, dust, even light itself vanish past the horizon, swallowed into darkness. But in physics, there is a rule as firm as gravity itself. Information cannot be destroyed. The details of a system, its patterns, its quantum states, must always persist, even if transformed. So what happens to the information locked inside a black hole? This puzzle is called the black hole information paradox, and it has unsettled scientists for decades. In the 1970s, Stephen Hawking discovered that black holes are not entirely silent. They should slowly leak energy, glowing faintly with what we now call Hawking radiation. Over unimaginable timescales, this radiation could cause a black hole to shrink and evaporate away. But if the black hole vanishes, where does the information go? If it is destroyed, then the laws of quantum mechanics break. If it survives, then somehow it must escape hidden in the radiation or imprinted on the event horizon itself. Ideas bloom like stars around this mystery. Some suggest that the event horizon holds a hologram of everything that falls inside, a cosmic ledger written on the black hole's surface. Others imagine that black holes might connect to distant regions of space, slipping information through unseen tunnels. Still others whisper that our understanding of physics itself must change, that we are missing a piece so fundamental that it could rewrite reality. The paradox is more than an abstract riddle. It touches the foundations of science itself, the question of whether the universe keeps perfect track of its story, or whether some details are erased forever. As you breathe slowly now, picture a library in the dark. Every book that enters seems to vanish, yet somewhere, in ways we do not yet grasp, the story remains. Black holes remind us that even in silence, even in shadows, nothing is ever truly lost. In the quiet of the 1970s, Stephen Hawking made a bold and surprising prediction. Black holes, those hungry giants of the cosmos, are not completely black. At their edges, where gravity bends reality itself, strange quantum effects whisper into existence. Tiny particles flicker at the horizon, and in the faintest trickle of light, the black hole begins to glow. This faint glow is called Hawking radiation. It means that black holes are not eternal. Over immense spans of time, they should slowly leak away their energy, shrinking, and eventually evaporating entirely. Even the most massive black hole, given enough ages of the universe, could vanish into nothingness. And yet, no one has ever seen this radiation directly. Real black holes are surrounded by blazing disks of gas and violent storms of energy, too loud, too bright, too chaotic for us to hear the delicate whisper of Hawking's predicted glow. Laboratory experiments have tried to create analogues, simulating event horizons with sound waves or light, hinting that the effect might be real. But the true proof still lies hidden in the stars. If Hawking radiation exists, it ties together the deepest pillars of physics: quantum mechanics, relativity, and thermodynamics. It says that black holes are not only engines of destruction, but also sources of warmth, with a temperature and a lifespan. It suggests that even the darkest places in the universe are not beyond the reach of light. But if it does not exist, then something even stranger must be happening at the edge of black holes, something we have not yet imagined. As you rest, imagine the night sky, filled with invisible candles. Each black hole glows softly, faintly, with light we cannot yet see, reminders that even in the deepest darkness, the universe carries within it the seeds of renewal. Black holes are often seen as endings, cosmic graves, where matter and light vanish forever. But some of the mathematics tells a different story. In certain solutions to Einstein's equations, a black hole is not only a trap, but also a bridge, a tunnel that may lead to another region of spacetime, or perhaps to another universe altogether. These tunnels are called wormholes. No one knows if they exist in reality. They may collapse too quickly for anything to pass through. They may be unstable, tearing apart anything that dares to enter. And yet, the idea lingers that hidden within black holes are passages beyond imagination, doorways to realms we cannot yet see. Some physicists even wonder whether black holes might act as seeds, giving birth to new universes on the other side. In this view, Our own cosmos may have sprouted from a black hole in some larger parent universe, its laws of physics written in the collapse of another world. If true, then creation and destruction are woven together, each black hole a potential womb as well as a tomb. Of course, we cannot test these ideas. The event horizon is a one-way boundary. No message, no signal, no traveler can cross back to tell us what lies within. And yet the possibility itself, that black holes are not only ends but beginnings, makes them some of the most tantalizing mysteries of all. As you drift in thought, picture yourself standing at the edge of one. Behind you, the familiar stars. Ahead, a circle of pure darkness. Is it an end, or is it a door? The answer remains sealed, hidden by silence. In the beginning, the universe was dark. After the Big Bang, for hundreds of millions of years, there were no stars, no galaxies. Only vast clouds of hydrogen and helium drifting through an expanding cosmos. It was an age of silence, a time before light. Then, slowly, gravity began to gather those clouds. Pockets of gas collapsed under their own weight, heating as they fell inward. Somewhere, in that ancient darkness, the first sparks ignited. The first stars were born. These stars, called population 3 stars, would have been enormous, hundreds of times the mass of our Sunday. They blazed fiercely, shining with a brilliance never seen again. But their lives were brief, only a few million years, before they died in colossal explosions. In their fiery deaths, they forged the first heavy elements, carbon, oxygen, iron, scattering them into space. Without these first stars, the universe would have remained barren, unable to build planets, unable to host life. And yet, we have never seen one. They lived so long ago, and so briefly, that direct evidence of them has slipped beyond our reach. We search for their traces in the chemical fingerprints of ancient stars and in the faint glow of the early universe. Telescopes like James Webb may one day glimpse their light across billions of years, a faint echo of the moment when the cosmos lit its first lamps. It is humbling to remember that everything around you, the iron in your blood, the calcium in your bones, was once forged in the death of these first stars. They were the true alchemists, turning the simple gases of creation into the elements of life. As you breathe now, imagine the first dawn of the universe, a single star flickering into existence in a vast ocean of dark. Then another, and another, until the sky was no longer empty but filled with light. Not long after the first stars lit the cosmos, something even stranger appeared. Astronomers looking deep into the early universe have found quasars, brilliant beacons powered by black holes, billions of times more massive than our Sunday. And yet, these giants existed less than 1 billion years after the Big Bang. How could such enormous black holes form so quickly? We know that black holes can grow when stars collapse, feeding on gas and dust. But to swell into monsters so soon after the dawn of time seems almost impossible. Even if they consumed matter at the fastest rate allowed, there may not have been enough time. Some theories suggest that the first stars were so massive that they collapsed directly into giant black holes, skipping the small stages. Others imagine clouds of primordial gas collapsing straight into black holes without ever forming stars at all. And still others wonder if new physics might be required, some hidden process that sped up the growth of these ancient giants. What we know for certain is that these early black holes reshaped the young universe. Their blazing quasars lit up the darkness, their gravity sculpted galaxies, and their presence echoes still in the structure of the cosmos. Without them, the universe we see today would not exist in the same way. And yet, their mystery remains. How did such titans rise so fast, in a universe still taking its first breaths? The question drifts unanswered, like a deep note in the song of creation. As you close your eyes, picture the early cosmos, stars just beginning to burn, and already, at the heart of galaxies, vast black holes humming with power, like drums beating at the dawn of time. As the first stars and black holes appeared, the universe began to gather itself into larger structures. Gravity, patient and tireless, pulled stars into clusters, and clusters into spiraling islands of light. These became the first galaxies, vast cities of stars, swirling through the expanding cosmos. We are still not certain how they formed. Did small clusters of stars merge slowly, growing into larger shapes over billions of years? Or did great sheets of gas collapse all at once, creating galaxies in a single sweep? The truth may be a blend of both, a cosmic dance of building and merging. What we do know is that galaxies quickly became the universe's great homes. Each one is a collection of billions, sometimes trillions of stars, held together by the invisible hand of dark matter. Our own Milky Way is just one of these galaxies, a spiral among countless others. And yet, it feels special to us, for it is the one that carries our sun, our earth, our story. When we look outward, we see galaxies stretching across the sky in every direction, scattered like jewels on a black velvet cloth. They form webs and filaments, vast structures spanning hundreds of millions of light years, like the threads of a cosmic tapestry. Between them lie immense voids, silent expanses, where almost no galaxies live at all. Galaxies are not only the stage for stars, but also the engines of creation. Within their spirals and clusters, stars are born, live, and die, enriching the cosmos with the ingredients of planets and life. Without galaxies, the universe would be a scattering of lonely stars, never gathering into the grand structures we see today. As you breathe slowly, picture yourself drifting beyond the Milky Way, past spirals and clusters, until you see the great web of galaxies stretched across the cosmos. Each one a city of light, each one with its own story, its own suns, its own possibilities. And within these galaxies, there is another wonder waiting the stars themselves, their births, their lives, their deaths, each one a chapter in the universe's long story. Stars are the beating hearts of galaxies, the glowing furnaces that light the universe. Each one begins as a cloud of gas, drifting and silent, until gravity gathers it in. As the cloud collapses, it heats and compresses, and deep within its core, something extraordinary happens. Nuclear fusion. Hydrogen atoms merge into helium, releasing light and warmth. A star is born. For millions, even billions of years, stars live in balance. Gravity pulls them inward, while the fire of fusion pushes outward, keeping them stable, like a candle flame holding steady in the wind. Our sun, too, rests in this balance, a quiet star halfway through its long life, shining gently on the earth. Yet every star carries within it the seeds of change. Small stars burn slowly, glowing for trillions of years. Larger stars live bright but brief, consuming their fuel quickly before collapsing in spectacular deaths. When the fuel in their cores runs out, the balance breaks. Some swell into red giants, shedding their outer layers in soft, glowing shells. Others explode as supernovae, scattering heavy elements into space, gold, carbon, oxygen, the very ingredients of life. In death, stars create. Their ashes become the dust that forms planets, oceans, forests, and even our bodies. Every atom of iron in your blood, every bit of calcium in your bones, was once forged in a star's fiery heart. To look at the night sky is to look at the ancestors of our own existence, and some stars leave behind dense remnants, white dwarfs, neutron stars, and black holes. These are the quiet echoes of stellar lives, reminders that even after death, stars continue to shape the cosmos. As you drift in thought, imagine the cycle: clouds becoming stars, stars seeding new worlds, worlds giving rise to life. It is a story that has played out countless times, across billions of galaxies, and through it all, the universe whispers the same truth: endings and beginnings are woven together. When stars reach the ends of their lives, they do not simply fade away. Their deaths are some of the most powerful events in the cosmos, endings that also become beginnings. Small and medium stars, like our sun, end gently, They swell into red giants, their outer layers drifting outward to form glowing clouds of gas called planetary nebulae. What remains is a white dwarf, a dense ember the size of Earth, glowing faintly for billions of years as it slowly cools. But massive stars write a different story. When their fuel runs out, gravity overwhelms them. Their cores collapse, and in an instant, the star explodes as a supernova. For a brief moment, it shines brighter than an entire galaxy. In that fiery death, elements heavier than iron are forged. Gold, uranium, platinum scattered like seeds into the universe. Even more violent are neutron-star collisions. When two of these stellar remnants spiral together and merge, they release a storm of energy and create some of the rarest elements in existence. In their crash, entire mountains of gold and precious matter may be formed in an instant, then flung across the galaxy. Without these cataclysms, there would be no rocky planets, no oceans, no living beings. The air you breathe, the jewelry you wear, the blood in your veins, all were created in the deaths of stars. Every atom heavier than hydrogen or helium was once born in fire. So when you look at the night sky, you are not just seeing distant lights. You are seeing the story of your own origins, written in starlight. We are, as Carl Sagan once said, star-stuffed fragments of ancient suns, brought together in the shape of human lives. As you rest, imagine the cosmos as a garden, where stars live, die, and scatter their seeds, so that new stars, planets, and perhaps new forms of life may grow. Even in destruction, there is creation. When the most massive stars die, their cores collapse into something extraordinary. Neutron stars. Imagine taking the mass of our sun and squeezing it into a sphere no larger than a city. The result is matter so dense that a teaspoon of it would weigh billions of tons. These are neutron stars, tiny, but unimaginably heavy, the remnants of stellar giants. Neutron stars are strange worlds. Their crusts may be harder than diamond. Their interiors are seas of neutrons, particles packed together in ways we cannot fully comprehend. Some theories even suggest that deeper within, matter dissolves into quarks, the most basic building blocks of reality, forming a quark star. Many neutron stars spin rapidly, turning hundreds of times each second. As they rotate, they beam out streams of radiation from their magnetic poles. If those beams sweep across Earth, we see them as pulses of light, like the flashes of a cosmic lighthouse. These are pulsars, ticking steadily in the night, some so precise they rival atomic clocks. Others are magnetars, neutron stars with magnetic fields trillions of times stronger than Earth's. Their energy is so fierce that it can twist atoms apart, reshaping matter itself. In rare bursts, magnetars release flares brighter than anything else in the galaxy, for a brief instant, outshining the stars around them. Though they are remnants of death, neutron stars are also keepers of rhythm and light. Their pulses echo across the cosmos, steady reminders of the cycles that govern the universe. As you breathe slowly, imagine these tiny stars spinning in silence, scattered like hidden gems across the galaxy. They are small, but their voices carry far whispers of collapsed suns, still singing through the void. The cosmos is not only vast, it is finely balanced. Every star, every galaxy, every breath we take exists because of a delicate harmony among the fundamental forces of nature. There are 4 of these forces. Gravity, the weakest yet most far-reaching, gathers matter into stars and galaxies. The electromagnetic force shapes light, chemistry, and life itself. The strong nuclear force binds the hearts of atoms, holding protons and neutrons together. The weak nuclear force allows stars to shine, enabling fusion to transform simple elements into heavier ones. If any one of these forces were just a little different, the universe would not look the way it does. Too much gravity, and everything would collapse too quickly. Too little, and stars could never ignite. If the strong nuclear force were weaker, atoms would fly apart. If stronger, fusion might not happen. Even the tiniest shift would erase the possibility of life. Scientists sometimes compare this to a symphony, each force an instrument playing in tune. The harmony has lasted for billions of years, allowing the cosmos to grow and evolve into the universe we see. And yet, this balance raises questions. Why do the forces have these particular strengths? Why do they fit together so precisely? Some believe the answer lies in chance, others in deeper principles we have not yet discovered. It may be that our universe is just one possible arrangement, one melody among many. But as you rest, it is enough to feel wonder at the balance itself. The same laws that move galaxies also guide the spark of a firefly, the beating of your heart. You are not separate from the cosmos, you are woven from the same music. The universe has a past, a present, and one day it will have an end. But what that end looks like is still a mystery. Scientists imagine several possible fates, each one shaped by the balance between gravity and dark energy. If dark energy continues as it is, the universe will keep expanding forever. Galaxies will drift farther apart, stars will burn out, and the night sky will slowly fade to black. Over unimaginable spans of time, even black holes will evaporate, leaving behind a silent, cold cosmos. This is called the heat death, a universe not destroyed in fire, but in endless quiet. If dark energy grows stronger, the expansion may accelerate without limit. Galaxies, stars, planets, and eventually even atoms could be torn apart in an end known as the Big Rip. Reality itself would unravel, carried away on a tide too powerful to resist. But if dark energy weakens, gravity could regain control. The expansion might slow, stop, and reverse. Galaxies would begin to fall back together. Stars would collide, and the universe would collapse inward in a final blaze called the Big Crunch. Some wonder if such a collapse could give birth to a new Big Bang, starting the cycle again. There is even the possibility of something stranger, that our universe might one day tunnel into another state, its laws of physics suddenly shifting. Such an event, called vacuum decay, would change reality itself in an instant. Though the odds are uncertain, the idea reminds us that even the rules of the cosmos may not be permanent. For now, the future remains unwritten. Billions of years stretch before any of these fates could arrive. To us, the universe feels eternal, carrying stars and galaxies onward in their slow, graceful dance. As you breathe gently, imagine the cosmos as a great story. You are living within one chapter, but the book is not yet finished. The ending lies far beyond our sight, waiting in the quiet of time. For all the vastness of the universe, one of its greatest mysteries lives within us. Out of stardust and chemistry, out of the quiet laws of physics, something has awakened that can wonder, reflect, and dream. We call it consciousness. Science can describe the brain in exquisite detail. Billions of neurons, firing in patterns, exchanging signals in tiny sparks of electricity and chemistry. But how does this web of activity give rise to the feeling of being alive, the sense of self, the inner world of thoughts, emotions, and awareness? This is the puzzle often called the hard problem of consciousness. Some believe it is an emergent property, arising naturally when matter reaches a certain complexity. Others suggest that consciousness may be woven more deeply into reality itself, not just a product of the brain, but a fundamental part of the universe, like space, time, and energy. No matter the explanation, the fact remains. The universe has given birth to beings who can ask questions about it, who can gaze at the stars and wonder where they came from. Through us, the cosmos is reflecting on itself, aware of its own existence. Perhaps this is why the mysteries of science feel so personal. When we ask why the universe exists, or how it will end, we are also asking about ourselves, about our place in the grand story. As you rest tonight, let this thought soothe you. Your awareness, fragile and fleeting, is part of the great mystery, no less wondrous than galaxies or black holes. You are the cosmos thinking, feeling, and dreaming in human form. And with that dream comes another question. gentle but profound. Are we alone, or is consciousness scattered among the stars? On our small blue planet, life has flourished for billions of years. From the tiniest microbes to forests, oceans, and human minds, Earth is filled with living breath. But when we lift our gaze to the stars, a question rises softly. Is life unique to us, or is it scattered across the cosmos? The universe is vast beyond imagination. There are more stars than grains of sand on Earth's beaches, and many of those stars host planets. Astronomers have already discovered thousands of worlds orbiting distant suns, some rocky like Earth, some gas giants like Jupiter, some scorched, some frozen. Among them are planets in the habitable zone, where liquid water might flow, where conditions could be gentle enough for life to emerge. Yet so far, the silence remains. No signal has reached us. No distant voice has called across the dark. This puzzle is known as the Fermi paradox. If the universe is so full of worlds, where is everyone? Perhaps life is rare, a delicate flame that flickers only rarely in the vast cold. Perhaps civilizations rise and fall before they can cross the stars. Or perhaps the universe is alive with beings, but the distances are too great, the signals too faint for us to hear. Still, the search continues. Telescopes scan distant skies for chemical fingerprints, oxygen, methane, water vapor hints that a world may be breathing. Radio antennas listen for patterns, for whispers of intelligence. One day, perhaps, we will find proof that we are not alone, or perhaps we will remain the only voice we know. Either way, there is wonder in the question itself. To look up at the night sky is to imagine other skies, other oceans, other beings, looking back. Life, whether rare or abundant, is the universe's way of awakening to itself. As you rest, picture distant planets under alien suns, seas that glow with strange colors, forests swaying in winds we cannot yet feel. Somewhere, perhaps, life stirs quietly, as it once did here, under the light of a young star. For as long as humans have looked upward, we have dreamed of traveling beyond our world. First came ships across oceans, then rockets to the moon, then probes to the distant edges of our solar system. But the stars, so close in the night sky, remain impossibly far. The nearest one, Proxima Centauri, is more than 4 light-years away. With today's spacecraft, the journey would take tens of thousands of years. To reach the stars, we would need new ways of traveling sails, pushed by starlight, engines powered by fusion, or technologies not yet imagined. And yet, even if the stars remain distant, exploration continues. Robots wander the surface of Mars. Telescopes peer into the atmospheres of faraway planets. Spacecraft drift beyond the orbit of Pluto, carrying with them messages from Earth, golden records of music, greetings and images, whispers sent into the dark. Perhaps one day, human beings will walk on another world, will build homes under alien skies. Perhaps our descendants will carry Earth's story into the galaxy, spreading life among the stars. Or perhaps our exploration will remain inward, through thought, imagination, and dreams. What matters is not only the destination, but the act of reaching. Every step outward is also a step inward, reminding us that we are part of something larger. The urge to explore is not only curiosity, it is the cosmos itself, through us, stretching its hands into the unknown. As you breathe, imagine yourself aboard a quiet ship, drifting among the stars. The windows open onto infinite night, galaxies glowing like lanterns in the distance. You are safe, you are carried, and the journey never ends. Science often feels like a search for answers, equations, experiments, proofs. Yet, at its heart, it is also a search for wonder. Every discovery, from the smallest particle to the largest galaxy, is not only knowledge, but also a doorway into awe. The mysteries we have touched tonight, dark matter, dark energy, black holes, the life of stars, the question of consciousness, remind us that the universe is not a solved puzzle, but an unfolding story. Each answer leads to deeper questions, each discovery to wider horizons. Science does not erase wonder, it deepens it. And wonder, too, is a kind of truth. To feel awe at the night sky is to stand in the same place as the first humans who looked upward with firelit eyes. To ask why we exist is to share in a question older than history. Science gives us language for these mysteries, but it is our sense of wonder that gives them meaning. In this way, science and wonder are not opposites. They are partners, like light and shadow, thought and dream. Together, they allow us not only to understand the cosmos, but to feel at home within it. So as you rest now, let the mysteries be your comfort. Let the questions cradle you, not as puzzles to be solved, but as gentle reminders that you belong to a universe vast and alive. You are made of stardust, bound by gravity, lit by sunlight, carried by time, and within you, awareness flickers the cosmos reflecting on itself. The journey does not end here. Each night sky, each quiet moment, is another invitation to wonder. And as you drift towards sleep, know that you are part of the great unfolding a note in the cosmic song, timeless and serene. And so, our journey through the mysteries of the cosmos comes to a quiet close. From the birth of the first stars to the questions of consciousness and the fate of the universe, we have drifted together through wonder, not to solve every puzzle, but to rest in the beauty of not knowing. As you lie here now, feel the calm of the night around you. The same laws that guide galaxies also guide your breath. The same stardust that glows in distant nebulae flows in your veins. You are not separate from the universe, you are its living, dreaming part. Let the questions stay with you, not as weights, but as lullabies. The cosmos does not demand answers tonight. It only asks that you listen, that you feel its rhythm, and that you let yourself drift into rest. So close your eyes. Imagine the stars above as lanterns glowing softly, watching over you. The universe is vast, but you are safe within it. Sleep well, dream deeply, and may your dreams carry you farther than the galaxies, into the endless wonder of existence. Good night.